A relation is a set of ordered pairs. So the set of ordered pairs can be on a graph, it can be in a mapping, it can just be a list of ordered pairs. So a function is a relation in which for each x has one unique y. So an x value couldn't have two different y values. So in this case, I'm going to graph this function. So -1, 4, 3, or graph the relation because we don't know it's a function yet. 3, 4, -1, 6, 2, 6. So is this a function? Is this relationship a function? No, it's not, because -1 cannot go to 4 and -1 goes to 6. So each x does not have a unique y. And then the domain are all the x values. So I'm going to list it as a set. So I'm going to use set notation. In domain, you want to list from least to greatest the numbers for x. And then don't repeat. So I don't need to list out -1 twice. And the range is list all the y values from least to greatest. So 4 and 6. So 4 and 6 are the only y values. To create a mapping of the relationship above, this right here is a mapping. So you have a set, you have a domain, and you have your range. So you list your domain, -1, 2, 3. You list the range for 6. And then you're going to match up based on right here that -1 matches with 4, 3 matches with 4, -1 goes with 6, and 2 goes with 6. And you can see that it's not a function because -1 has 2 lines going out of it. And you can also see that this is not a function by using what's called the vertical line test. So I'm just going to do examples of the vertical line test. So up here, this function does not pass the vertical line test because when I draw a vertical line, it crosses through an x value twice. The blue line crosses the function twice. As soon as it crosses twice or more of every vertical line that you could possibly draw, it's not a function. So I'm going to use the vertical line test right here to show you whether or not it's a function. So if I drew an infinite amount of vertical lines, I could see that this blue line crosses this red relationship. It's not a function twice. Crosses right here, it crosses right here on this same vertical line. So no, this is not a function. If I drew an infinite amount of vertical lines on this relationship, yes, it is a function because it doesn't cross twice. If I drew vertical lines right here, no, it's not a function because these two cross twice, so no, it's not a function. We can use function notation, which basically is, instead of using our traditional y equals something with x, we're replacing the output or the dependent variable with f of x. So therefore, if you have f of x equals x plus 5, and you're trying to find f of 2, that means you need to replace the x with a 2. So f of 2 would be 2 plus 5. F of 4 would be 4 plus 5. F of y would be y plus 5. You're just replacing the independent variable in the function. So if you have f of x equals 1/3 x plus 1/2, to find f of -1, you do f of -1 equals 1/3 times -1 plus 1/2. So you're adding up -1/3 plus 1/2. So since this is starts in a fraction, I want to answer my question I want to answer this in a fraction. I don't want to end with a decimal. So negative 1/3 plus 1/2, you need to get a common denominator. So 6, this is 3/6, this is negative 2/6, so the answer is 1/6. So you can go ahead and do negative 3, plug in, 6, plug in. Now what this one means is, this notation means I'm multiplying negative 4 times f of 1. So first I do f of 1 and then I multiply it by negative 4. So f of 1 is f of 1 equals 1/3 times 1 plus 1/2. So this is going to be 2/6 plus 3/6. So f of 1 equals 5/6. But now remember, it's negative 4 times f of 1. So it's negative 4 times 5/6. So I can reduce negative 4/6 is negative 2/3. So I'm going to multiply my numerators. Negative 2 times 5 is negative 10, and my denominator is 3. So it's negative 10/3. Okay, number 6. The function for a bank account's balance B for an account starting with $100, earning an annual interest rate of 4% and left untouched for n number of years can be calculated using this function. So if you left it in for 1 year, B of 1 would be 100 times the quantity 1 plus 0.04 taken to the first power. So calculate B of 0. So that means plug in 0 for n. And what does it represent? So anything to the 0 power is 1. So this answer is going to be $100. Now what does B of 0 represent? So remember that n represents years. So this means initial amount. So we know initially we have $100 just from our function and from what the words up here say. Calculate B of 15. What does it represent? So B of 15 is B of 15 equals 100 times 1 plus 0.04 to the 15th. So you do order of operations. Do 1.04 to the 15th. So I do parentheses, exponents, and then multiply it by 100. And whatever you get for your answer, it's money, so you should round to 2 decimal places. What does it represent? It represents the amount after 15 years. So the amount of money that you have in your account after 15 years. So this is function notation. Functions are for each x there's one y. You can find the domain and range by a list of ordered pairs, but the more difficult part is from a graph. So if you have a graph that's just not a bunch of ordered pairs, you actually have to think about all the possible x's and y's that you could possibly have. So for the domain, what I do is domain is the x. So you want to look at how far to the left and to the right this function goes. So if I look over here, it ends to the left with an arrow. So this arrow means it's going infinitely. So this function for domain covers everything from left to right. So if it covers everything from left to right, the domain is x such that x is all reals. That's a set notation. Or you could do negative infinity, x infinity. Or for the interval notation, it would be negative infinity to infinity. Sometimes, so in between here, I was a little hesitant, we can also write an E. The E looks like this. So this means that x is an element of all real numbers. And now we're going to look at our range. So our range is how much is it going in the up and down. So the y's, how far does it cover the y's? So what I do, just like I start on the left hand side, I'm going to start down. So are there any y's down here? Nope, because it's just going straight across. So when I start at the bottom, the y's only go up and down from here to here. The y values stay in between -2 and 2, and includes -2 and 2. So the range is the y value such that y is between and including -2 and 2. So these are going to have brackets for the range. And the second one, so how far are we going left and right over here? Well, if I looked over here, the function's not over here. The function starts on the number line at 0. So the domain is everything that's at least 0. So it's x such that x is greater than or equal to 0. So interval notation would be it starts at 0 and goes to infinity. Range is how much is it going up and down. So this parabola goes on forever up and down. So the range is y such that y is an element of all real numbers. And we're going from -infinity to infinity. And the last one, look at going side to side with the domain. Look at it, the x values going side to side. If I start over here on the left hand side, this arrow is going infinitely to the left, and this arrow is going infinitely to the right. So the domain is all real numbers. So if I do the interval notation, the interval notation is going to be -infinity to infinity. And then the range, start it down at the bottom. Are there any y values down here? No. I'm going up, 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 starts right here and goes up. So the range is going to be y such that y is greater than or equal to 2, because it's starting at 2. So it's going to start at 2 and go to infinity.